Hello students, this is Dr. V. Siva from IARE. Today we are going to discuss definition terminology of Module 5 in Analog and Digital Communication course. Okay. Now the fifth module which contains spread spectrum techniques and error control codes. So this module is covered by two outcomes. One is CO5 and another is CO6. CO5 states that identify the importance of spread spectrum techniques for secure digital communication systems. CO6 is build the block codes for error detection and error correction in noisy environment. Okay, so these are the course outcomes. Now coming to the definitions. What is error coding or error control coding? Error control coding is used to enable the receiver to detect or correct the errors by introducing some redundancies into the data to be transmitted. Here they are adding some redundancy. What is meant by redundancy? Redundancy means not essential bits. Not essential bits. So those bits are not essential. They are not the information. But we are going to add in those redundancy into the data and we are detect the errors and correct the errors by using the redundancy. So when you go for the linear block code, we can see such type of arrangement. What that one? Check bits, parity check bits, or simply parity bits. We are adding parity bits. So we know that it is in the form of n comma k. N is the length of the code, k is the length of the message bits. So what is n minus k? This is parity bits. N minus k parity bits is going to add it to k message bits. Then finally it is what we require the code. So we know that how that n minus k parity bits are added and how n bit of code are generated. Already seen that previous videos. Okay. So here we are discussing only the definitions. Next, what is systematic codes? In the systematic block code, the message bits appear at the beginning of the code word. The message appears first and then check bits are transmitted in a block. So this type of code is called systematic. Message bits are first and then is check bits or parity bits. So for example, 1110 So in this code, if it is systematic code, this is one is systematic code. So the first bits are message and this next three is check bits. For example, this is a n comma k or 7 comma 4. So what is for message bits? So these four are called message bits. And the next three, what these three? N minus k parity. So 7 minus 4, we got 3 parity bits. So these 3 parity and 4 message bits. So 4 plus 3, so 7. This is the length of the code. This is the code length. So the code having 7 bits length. In this 7 bits, 4 message bits, 3 parity bits. Okay. So in any code word, first appear the message bits and next it is check bits. It can be called as systematic. For systematic bit, for systematic codes, the generator matrix having arrangement GIKP form. The generator matrix must be in this format. IK argument of P. Then we can get the systematic code. If it is altered, then it can be non-systematic. Okay. So what is non-systematic? In the non-systematic block code, it is not possible to identify the message bits and check bits. They are mixed in the block. They are mixed in the block. What is a block coding? The encoder generates a block of encoding bits from k information bits called n, k block codes or code word symbols. Already shown n, k. N is the length of the code. What is linear block coding? If the sum of any two code words is a code word, then the code is said to be linear. So it is called linear block coding. What is generator matrix? In coding theory, a generator matrix is a matrix whose rows form a basis for a linear code. The code words are all of the linear combinations of the rows of this matrix. That is, a linear code is the row space of generator matrix. So, for generation of the code, G must be. Generator matrix is must. Without generator matrix, we can't generate the code. Okay. What is parity check matrix? A parity check matrix of a linear block code is a matrix which describes the linear relations between the components of a code word. It can be used to decide whether a particular vector is a code word and is also used in decoding algorithms. So, how to represent this parity check matrix? H. H is P transpose argument of in minus k. So, this is representation of parity check matrix. So, this parity check matrix is very useful for calculating the syndrome. Syndrome is nothing but S into R power H transpose. Okay. What is Hamming codes? Hamming code is a set of error correction codes that can be used to detect and correct the errors that can occur when the data is moved or stored from the sender to the receiver. So it is developed by R.W. Hamming. So it can be called as Hamming codes. What is Hamming weight? Hamming weight is defined as the number of non-zero elements of C. Of C means it is code. For example, the Hamming weight of a code is here how many non-zero elements? Here 1, 1 and this 1, 1. So 4 ones are there. So these can be called as 4 non-zero elements. So the weight of this code is 4. For example, here 1, 1. So how many non-zero elements are there? So what is the weight of this code? Is nothing but 3. Okay. What is the Hamming distance? D. Hamming distance D is defined as the number of places where they refer. For example, the Hamming distance D of C of x. 2 vectors or 2 codes are considered. So out of these 2 codes, how many places are differ? So here you can see first 1 is there and here 0. So 1 variation. Again second bit, there is a variation. Third bit, there is a variation. So fourth bit, no variation. Fifth bit, no variation. Again sixth bit, there is a variation. Okay. So again this bit and this bit. So how many variations were considered? Okay. So these variations here, how many you are getting, that can be noted here. 4 variations, 4. 5 variations, 5. Okay. So in this way, we are going to compare for each bit and that variations we are going to take count, that is Hamming distance. What is the minimum Hamming distance? Minimum Hamming distance. So minimum Hamming distance is defined as the smallest distance between any pair of code vectors in the code. Smallest distance between any pair of code vectors. So in previously we calculated the minimum, how many variations. So for example, one code having 5 variations and another having 3 variations. So we consider the smallest variation, the smallest distance between any pair of code vectors we are going to consider. Okay. What is cyclic codes? In coding theory, cyclic code is a block code, or it can be called as a subclass of block code, where the circular shifts of each code word gives another word that belongs to the code. So it follows the circular shifts. The cyclic code which follows the circular shifts of each code word gives another word that belongs to the code. Now what is code rate? The ratio of the number of input bits k to the number of output bits n is called code rate. It is a measure of the efficiency of the code. So generally I think this code rate doesn't appear in block code or cyclic code. So it appears in the convolution codes. So code rate is considered the convolution codes. What is constraint length? The constraint length of the code represents the number of bits in the encoder memory that affects the generation of the n output bits. It is expressed by constraint length L equal to k into m minus 1. So this is the constraint length formula. How to measure or how to find the constraint length. Okay. What is metric? Metric is the discrepancy between the received signal and the decoding signal at particular code or particular node. At a particular node. So metric is discrepancy between the received signal and the decoding signal at particular node. Next, what is a syndrome decoding? Syndrome decoding is a highly efficient method of decoding a linear code over a noisy channel. That is one on which errors are made. In essence, syndrome decoding is minimum distance coding used using a reduced lookup table. So this is syndrome decoding. And another is, what is low density parity check code? LDPC. In information theory, a low density parity check code is a linear error correcting code method of transmitting a message over a noisy transmission model. So this is LDPC. Next, what is forward error correction? The forward error correction codes are those which add some redundant bits to the message bits, and the transmitted data consists of both message bits and redundant bits. So example of this forward recursion is block code and cyclic code. So these are the examples of this forward error correction codes. So what we discussed all are forward error correction. What is even parity check code? When the check bit is such that the total number of ones in the code word is even, then it can be called as even parity check. Okay, total number of ones are even, then it is even parity. What is odd parity check code? When the check bit is such that the total number of ones in the code word is odd. So for example, this is a 7 code, 7 length code, 7 bit length code. So now here ones are 4. So this is even parity. No, here only in check bits, not in all message bits. For example, here 2 ones, This is even. Or all ones for a 7 bit. So now it is 3. This is odd parity check code. Okay. What is random errors? Random errors are created due to the white Gaussian noise in the channel. It does not affect the performance of the system in subsequent intervals. So it is one type of errors. Random errors are created due to the white Gaussian noise in the channel. What is burst errors? The term burst error means that 2 or more bits in the data unit having changed from 1 to 0 or from 0 to 1. So these are the burst errors. More than 2 or more than bits are changed. Then you can call it as burst errors. Define redundancy. The central concept in detecting or correcting errors is redundancy. To be able to detect or correct errors, we need to send some extra bits with our data. These redundant bits are added by the sender and removed by the receiver. Their presence allows the receiver to detect or correct corrupted bits. So already we discussed it and we solved a number of problems on this redundancy. Okay. What is block interleaving? A block interleaver accepts a set of symbols and rearranges them without repeating or omitting any one of the symbols in the set. The number of symbols in each set is fixed for a given interleaver. So this is block interleaving. What is syndrome? If the syndrome is an all zero vector, then the received code is a valid code. If the syndrome is a non-zero vector, then the received code has errors. Okay. So here syndrome, we are going to calculate syndrome. S equal to R into H power T, where R is the received code, H is a parity check. So by using these two, we can find the syndrome. If the syndrome having all zeros, so it is a valid code. If there is a non-zero, for example, syndrome getting 0, 0 like that. So there is no errors in that code. The code is valid. Or like this. So this is errors. The first bit is an error. Okay, we are going to correct that first bit of parity. Then we are going to correct that. Okay. So syndrome is very, very helpful for detecting and correcting that errors. So define linear block code. It is a simple error control coding technique used for error detection and error correction. Define Golet codes. The 23 by 12 Golet code is the only 3 error correcting binary perfect code. The minimum distance of this code is 7. So here we can correct the errors for 3 bit. For linear block codes, we can correct only 1 bit at a time. Already we know that. We can correct 1 bit. We can detect 2 bits only. But the Golet codes, we can correct 3 errors. Okay. Define Reed-Solomon codes. Reed-Solomon codes are an important subclass of non-binary BCH codes. The encoder for an RS code operates on multiple bits rather than individual bits. Reed-Solomon codes have particular good distance properties and are useful in situations where errors tend to happen in bursts rather than randomly. So these are the Reed-Solomon codes. What is the objective of the channel encoder and decoder? The combined objective of the channel encoder and decoder is to minimize the effect of the channel noise. Okay? The main objective is to minimize the effect of the channel noise. How to achieve minimal channel noise? By encoder and decoder. Simply, just by introducing systematic redundancy into the data stream by adding bits to the message bits. So in such a way, facilitate the detection and correction. And the channel decoder in the receiver exploits this redundancy to decide which message bits are actually transmitted. Okay, so already discussed it. Define binary field. The set k equal to 0, 1 is a binary field. The binary field has two operations, addition and multiplication, such that results of all operations are in k. Okay, so this is binary field. And these are definitions in this module 5. And the content of information is taken from Computer Systems by Simon Hacking, 3rd edition, Sanjay Sharma, and J.S. Chitori. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.